Thanks for hopping on and doing the coding interview. From what
Yeah.
I all I know about you right now is you solved 100 leak code questions and you're based in the U.S. Is there anything else you'd like to share, like what school you go to, or
Yeah, I mean, I just completed a master's from like a small state school, and
mm,
then also I'm prepping for interviews. So like I have an interview coming up, so I was just working on stuff. Yeah.
nice? So
hmm
do you? How long have you been working, or are you a student?
So I've been working for about like around 3 years.
Oh wow, you've been in. Okay, so you've already worked, and then you went back for your masters, and then now you're
Yeah,
graduating.
so I was doing like masters, and I was also like working as well. So.
Nice. What area, or sorry, like are you a SWE right now?
Oh yeah, yeah.
Okay,
I'm
cool.
I'm like I'm doing like technically I'm doing data engineering stuff right
Yeah.
now, but like the official title is still well like yeah, software engineering basically.
So how are you at LeetCode? Are you pretty good?
I wouldn't say I'm that good. Like I still have like a lot of areas to work on. Um, but I'm trying to get better though.
Hmm.
Yeah.
So because yeah, you only did 100, so I don't know how hard of
Yeah,
a
so
question I can ask.
that's actually not fully true. I've done more than that. But that was like a long time ago when I was doing my bachelor's, which was like around like 2016, 2020.
Hmm.
But then I stopped because I was just working, and then after I started applying again, I started doing a bit more. So like the 100 is basically what I did maybe in the last year.
Nice.
So like like I know the general stuff, but I'm still not that confident because, for example, if it's not a problem that I've seen before, or if it's like a very hard problem, or like if the pattern is not that obvious, then I probably won't be able to solve it
Okay.
in an instant, especially under time pressure and all that.
Yeah. How like what language do you like to use?
I use Python for interviews.
Okay. And is anything not fair game, as in that I just shouldn't ask you, like DP or something?
I would say like since I have the interview coming up, I would say like let's do everything fair game because I probably that's how the real thing is going to be. So
Is it a company known to use DP?
is it's Amazon, so
Okay.
I don't think Amazon uses DP that much, right?
Yeah, I'm not sure. Okay.
I I've heard they don't use it that much, but
Sounds good. Okay. Okay, I got some good questions.
all right.
Let me bring up the first one. All right. This is a super popular Amazon question, so
Okay.
whip this up on here.
All right.
So we just want
Okay.
to generate parentheses, well-formed
Yeah.
parentheses.
Mhm. Given n pair of parentheses, write a function to generate all combinations of well-formed parentheses.
Exactly.
Okay, so like you can do you see when I highlight stuff?
Yeah, I see when you highlight.
Okay, okay. Yeah, so I think valid parentheses or well formed would be just like something. If something is open, then that has to have some sort of like close, right?
Yeah.
Okay. So maybe like if I see a opening, there's three open parentheses, and there's two that would be invalid.
Yeah.
Um, I probably want to use a stack here. So maybe in my stack, if I put the open parentheses like this, and then I see the close, then I can just pop that one out, both of these out. And then I see this again, I can pop that out, but I don't have anything else remaining. So that probably means it's not a valid parentheses. Is that a good estimation, or is there any edge
Well, we
cases that
we
I
don't
might be?
need to print if it's valid or not. We need to generate all of the valid ones.
Oh, my bad. Okay, so it's a different question. My bad. Okay,
Yeah.
all right. So given n pairs with the write a function generate all combinations of well-formed parentheses. Okay. All right. So yeah, this is a bit difficult then. Yeah. So if n equals to 3, so this is the output here. So if I'm thinking in terms of like the sort of choices that I have, are probably, let's say, obviously I need to start with since it's well formed, right? I need to start with the opening, and then I can either close that or I can open another one. So I close that, and then another one would be to just open another one. Um, and then we can do that like 3 times, maybe. And then so here as well, I have two choices. So open, I close that one, or I open this one, and then am I thinking on the right track? Like trying to like see that there's like two choices that you can make at each step.
Yeah,
Okay.
yeah. There's different choices you can make at each step. What are the choices?
You got a cut off there.
Wait, can you hear me?
Yeah, I can hear you now.
Yeah. So you said we're gonna make two choices. What are those two choices?
So what I said was basically, if I open a parentheses, right, I can probably either close it or I can open another one.
Yeah.
But I don't know if that captures all the cases because it could be something like
Okay.
uh,
So
open,
makes
open, open,
sense.
close.
Makes sense. I think I agree with that. So you make two choices. You can either open one or close one, but you could only really close one if you haven't
Uh-huh.
if you have enough open. So you could just kind of make some conditional there. But how are you actually gonna generate all of these parentheses? Like what algorithm?
Yeah, that's a good. Yeah, so what I'm thinking is something like a recursive approach. So like this would be my path basically. So I'll probably have like a function that recurses, and then I would call that. I would add something. I would add something to the path. So that would be how I would make the choice. So, yeah, but I don't know if this is the right way to solve this. So let me just think about it more. Given n pair of parentheses, write a function to generate all combinations of well-formed parentheses. And open, closed, closed, closed. Okay. Um. Yeah. So probably something like what I said before. So let's say I open this, I can either close that or I can again open another one. But I need to track all of this in my recursion. So
Yeah. I think you're going the right approach.
uh,
Go ahead and just try implementing it. And
okay,
yeah,
sure.
like maybe
Um,
you it might jog your memory once you start coding to see.
okay, okay. Uh,
Chat's asking when's your interview.
it was supposed to be like a week from now, but I think it's gonna shift because they kind of changed the teams up. So I'm kind of glad because I need more time to practice, especially like I need to like practice system design.
Yeah. How far can they push it back? the interview?
So I have a call. I have a call tomorrow. So I'm gonna ask them at least like 2 more weeks.
Okay.
But I don't know if that's enough
Yeah,
though.
we'll talk about it.
Yeah. Okay. So generate parentheses and then the recursion is probably going to be something like this. Um, so if I so if I close it, I probably need to decrease the count of parentheses that I have remaining. But sorry. Can I go back to the drawing board and try
Yeah,
to figure
go
this
ahead.
out?
Yeah, yeah.
Yeah, I don't really have anything like. Okay, so I need to generate all the parentheses that a function to generate. So basically, if either with this, close it up. So that means one is done. Um, so I think maybe this works, but I'm still not too confident on if this is a good approach. So what I'm trying to think is like what sort of state I need to track to be able to solve this. Because like what I said first was like if I started, I can probably do two choices, right? But I also need to know like how much. So for example, in this path, I've already finished this one of the parentheses,
Yeah.
right? So I'm just trying to think like because I also need to track that because this tells me that I need to uh, like I have like one to close, and then one more that I can open and close, so on and so forth. So that's why I'm trying to think of maybe keeping track of something like the number of open parentheses and then the number that I've closed, and then using those states to see like what the total number of completed are. And then if the total number of completed is less than n, then I can probably keep on going. Is this in the
Yeah.
right path, or I'm?
Yeah, you're going down the right path. I think you're just having trouble understanding what the recursion tree is gonna look like, or how you can do
Yeah.
recursion.
Do I need these states though? Like, is that overkill? Like the open close.
Yeah, you need to maintain some of the states. Like you need to
Okay.
know. The small hint I'll give you
Yeah.
is maybe try visualizing it as a recursion tree like this. So maybe
Yeah.
you
Yeah.
said we make two decisions, either open or
Yeah.
close.
Yeah.
So pretend we open,
Mhm.
and then what happens here?
You can either like open another one or close the previous one. Like you'll do both of those, I think.
Okay, you want to go both,
Yeah.
right?
Yeah.
So what's it called? Pretend n was 3.
Uh-huh.
Okay, what happens here? What decision can we make here?
Uh, so you started your you probably need to add another open another one, right?
You can
You can
open
open
another
another.
one, and you can close it too if you wanted.
Yeah.
Okay, what about here? What decisions can you make here? If n equals
Um
3.
yeah, so we would keep on sort of doing this until we ran out of, you know,
Yeah.
we completed. Yeah.
So at each level, you need to know n.
Yeah.
Okay. And then what other information do you need to know? Like you mentioned it earlier.
Yeah, like I said, like you probably need like the number of parentheses that are open, and then
Okay.
yeah, something like that.
Could
Yeah.
you pass? Yeah. Just would you be able to just? I agree. What happens if
Okay.
what does num open do? Like what do we understand with num open?
So with num open, let's say this was already closed. Like num open basically means I need to close that as well. So that means like that's how many like like closing parentheses I need.
Yeah, exactly. Basically, if
Okay.
num open is greater than 0, you can close it.
Oh yeah,
But then
yeah,
when
yeah.
you pass down to the children, you should subtract the num open because you closed one earlier.
Yeah, okay. Okay. Okay, yeah, I think this kind of makes sense. Yes, so okay. So at the start I have like my n equals to 3, and then the number of open parentheses is 0. So I start off with just the opening parentheses. Now when I send my state to my child, I'm going to say I have 1, and then um so that means since I have one num open, I can close it, and then I can also add another one. So in this case, num open would be num open would be 2 in this case, and then in this case num open would be 0, and then num would be uh, 2 because I can work on 2 more. Um, yeah, I think this makes sense. I think this is what I need.
Okay, go ahead and implement.
Okay, okay, so let me. Um, okay, so I have the n, and then I'm gonna say number of open. So the base case is going to be if n equals to 0. Uh, I'm just gonna use like variables because like I don't want to like deal with like trying to do this with just like returns. I'm
Yeah,
gonna
yeah.
not be able to do it right now. Okay, so if n equals to 0, that means I have completed everything. So on my path list, I'm just gonna paths list. I'm just gonna add the path. And then if num open is greater than 0, then I can generate parentheses. parentheses with um, n minus 1 and probably the same number of open parentheses. Oh, sorry. And then minus 1 num open and then path plus close it. Um, so if in the normal case, I'm just going to say pass in the same n and then num open plus 1 and then path plus open one more. Um, okay, so I'm just gonna try to dry run this scenario, see what happens.
Sure.
Okay, so for n equals to 3, we have n equals to 3 num open. Let me just say 3, 0, and then empty. So at the start, if n equals to 0, no, so that's a skipped. And then if num open is greater than 0, that's also skipped. So generate parentheses n3 num open plus 1 because it's open 1 and then just we just add this to the empty. Uh, so I'm just
I
gonna
mean, feel
follow
free
this.
feel free to actually just run the code and see what you get.
Okay, okay. Okay. Let's see.
Like debug by just running the code.
Yeah, I can do that. But that's not like allowed in interviews, right?
Depends. In Amazon,
Uh,
you can maybe
Amazon,
no.
you
I don't. I don't
they
think you
don't
can.
really run the code. I think
Yeah.
like you just have to do dry runs. Uh-oh.
You're in an infinite loop, I think. Yeah, you're in an infinite loop.
Uh,
Probably this
okay,
one.
so yeah, but yeah, most likely this. I think probably yeah. So when I open something, when I open something, I probably expended that. So I probably need to subtract that here. Uh, but in this case, I probably don't want to do it. Let's see.
I think you're still. There's still infinite loop.
Yeah. Okay. Let me just think about this. If n equals to 0, pass the path. Uh, oh, holy crap. Uh,
So what are you trying to find now? Like, why is it looping? Infinite looping?
oh yeah, that's what I'm trying to figure out.
Oh,
That's
look
what I'm
like
trying to figure.
it ran. Oh no, it halted.
Yeah. Um. So
I think it's your code there looks good. Or how is this
Yeah.
gonna help find the issue here?
Yeah,
Or
so I was just trying to dry run it because like I can try like printing stuff and then
yeah.
like try to figure out where it's wrong. But if I actually like fully understand the code, like probably will be better to find the
Hmm.
bug. That's why I was doing that.
Okay.
But
Like
I feel it's probably close to the solution. I don't know. What do you think?
yeah, I think right here you just need to return
Oh no
because
way.
what's happening is when it was
Oh
going
my bad.
through.
Yeah, that's God damn.
Okay, this is
Yeah,
what
but
it. This is it's
sorry.
returning something now. Doesn't look accurate.
Yeah, it doesn't look accurate. So it's returned for three. It returned one, two, three, one, two, two. Yeah, there's still some issues here. Um, so it looks to me like all the open parentheses at the end are not getting closed. Like this has like two at the end and then one at the end. This has one at the end, but the rest are getting closed.
Yeah, let's just try a
There's
smaller
one.
number. Two, just two parentheses. Sorry.
Okay. Uh, should I try to solve? Should I try to resolve this?
Yeah, try to resolve it.
Okay.
You
Okay.
want to test your
Fine.
debugging skills.
Okay. Okay. Yeah. So what we have is path, and then if n equals to zero, pass it up and path. If num open is greater than zero, um, we're saying pass the n. Um, 2, 0, 1, 1. Good. Uh, it's going here. It's closing that, so it's setting n to 1.
Well, if n equals 0,
Yeah.
what if we still have open paths?
Yeah, maybe. Yeah, I think maybe that's the problem. Um, so yeah, so here, 0 is n, and then 2 is the number of open, and then we still have that open, right? And here as well, we have this. So probably for uh,
Oh,
maybe it's working now.
yeah, it looks like it's working.
Oh, wait, let me delete this. Sprint final thing. It looks like it's working. Nice.
Nice, nice. Okay. What if I wanted to generate it? What if I wanted to generate the parentheses for also curly braces? This.
Yeah. So probably like probably just like pass in a like type or something. Oh, um, mm, mm.
Okay, wait. We're gonna move on to one last
Yeah,
question, cause yeah,
yeah.
you pretty much got this.
Okay, okay. Yeah, this was kind of scary, man. Like this kind of nerve wracking. Like this is good though. Like
It's what you
because
need,
I feel like
man. It's what
if
you
I was
need.
doing this in if I was doing this on my like own, I feel like I would like it would not have been this hard, but like just the fact that like, but I think this is good preparation for the interview though.
The next question. I'll let you go ahead and read that.
Okay. So you're given an m by n grid where each cell can have one of three values, which is zero representing an empty cell, one representing a fresh orange, or two representing a rotten orange. Every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. Return the number of minutes that must elapse until no cell has a fresh orange. Sorry. So this is a m by n grid, and then we have three possible values: empty cell, and then uh, some fresh oranges, and then we also have rotten oranges.
I'll give you an example.
Okay, okay,
So the output
okay,
of this should be four.
okay.
Do you see why?
Yeah, so let me just read the question. So I'm given a m by n grid where each cell can have one of three values. Zero represents an empty cell, one represents a fresh orange, and then two represents a rotten orange. Every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. So so in the first minute, basically one and one
Yeah.
um got rotten, and then second minute probably this and this got rotten, and then this and this got rotten.
Yeah.
But how does that make it four though? Isn't it supposed to be three? Like so, first minute like
Just put three right. Oh yeah. No, because
is it three?
no, because like the first one it spreads to these two, right?
Yeah, yeah,
Second it spreads to these. Third it spreads to
yeah.
this guy. Fourth it
Oh
spreads
yeah,
to
third.
this guy.
This guy. Okay, makes sense. Yeah. So okay. So okay. Yeah. So what I'm thinking of is like, like where are the rotten oranges? Where are all the rotten oranges, right?
Yeah.
So if I had a rotten orange here, then in the first minute, this would also be rotten, including this and this, right?
Hmm.
Um, so let's say I have like all the indices of the rotten oranges prepared. Um, and that could be like a bunch of different indices, and then I can say in the first minute, all what is- four directionally adjacent gets rotten. So that gives me an entirely new list of like new rotten oranges, and then I take that list. So this is basically each minute. Like this is so this is minute zero, and then this would be minute one, and then minute two, and so on and so forth. So I think this basically amounts to like a breadth first search
Mm-hmm.
from all the rotten indices.
Yep.
But written the minimum number of minutes that was allowed on the nose cell as a fresh orange. If this is impossible, return minus one. So in that case, if let's say I turn, let's say this was a 0, turn this into 2, 2, 2. So after I do this operation, right?
Yeah.
This maybe I can do like a iteration through the grid and then try to find the count of non-rotten oranges, fresh oranges,
Yeah.
and then if there is any, like I can say it's impossible.
Yeah. Makes sense.
Okay. Uh,
So what you're gonna do? Breadth first search, you said?
yeah, I think I'm leaning towards a breadth first search. Is that a good
Okay.
idea, or do you
Yeah.
is,
Go ahead. Makes
it's,
sense.
okay? All right. So def. Oh, uh, no. Let's just call it like rotten orange. I should just keep it. Mm, um, if grid of ij is rotten, then yeah. So 001011. So, okay. Yes. So once I find the rotten oranges, I basically have my first level. Um, Maybe I can start up a new queue, and then I'll basically say for uh, probably say what are all the directions I can go, and then go up. Um, um, so um, for okay. I Yeah, so for each of the indices in the queue, and then for each of the directions, I have to calculate the the new direction that I can take, which is going to be I plus dx and then j plus dy. And then if uh, di is greater than or equals to 0, and then is uh, it's not equals to uh, 0. Yeah. So if check if it's a valid, so check if it's a valid index. So if it is indeed a valid index, um, then I just put it in the new queue. But actually, do I need to? Uh, yeah. So I have a list of oranges, and then I check all the directions that I can go to, and then what am I doing here? One second. So I got the list of all oranges, rotten oranges, and then so four. Go back to index, and then yeah. So if that is a valid index, and then j equals to 1, then uh, now that gets rotten, and then I add that to the queue so that I can explore. What else do I need to do? Yeah, so I add that to the queue, and then
Like for a queue, are you using a queue or just a regular array?
oh yeah, this is just I'm just calling it. I'm just naming it queue, but it's just a regular array.
Okay.
So yeah. So now the queue is going to be the new queue. Okay, so let me just like run through this just to make sure if I have it right. And then I probably also need to increase the minute here as well. So okay, so I started off with like an empty queue, and then what I did was I just iterated through the grid, and then I collected all the rotten oranges, and then that's my starting point for the BFS. Initialized a variable to track the number of minutes passed. I just created this as like an easy way to represent
Yeah.
four directions. And then while we have something in the queue, I just started this up to like represent the new level.
Mm.
And then for each of the indices that I have currently in the queue, I just calculated the directions that I can go to, which would be the current direction added to the change, and so on and so forth.
Yeah.
And if that is a valid index, which would be, let me see if this is right. 0 is less than or equal to di, and then yeah. So if that's a valid index, and then if that is a non that is a fresh orange, then we probably need to make that a rotten orange. So I did that, and then since it's rotten, I can add that to the new queue, and then I just said now we're operating on this new queue. But where do I say that a minute has passed? So probably we'll do that here. Okay, so minute was passed, and then now finally what I need to do is uh, so the question is, the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. If read ij equals to 1. Yeah, I think this would be my solution. Do you want me to run it, or like do you have any like concerns about it?
Yeah. Sure. Run it on there and let's see what it gets. One.
Okay, let's see.
Shoot. Gotta fix this.
Wait, okay. Oh, yeah. Okay, print. -1. That's correct, I think, right?
It's it should be 4.
Because there's no rotten oranges,
Oh. Yeah.
right?
Yeah.
Yeah.
Put it 2.
Okay. All right. Oh shoot. Okay. So 2. It still returned -1. Okay. So directions, blah blah blah. Let me check what's in the queue at the start. Print queue. Okay, that's good. And then let me see what is in new queue. Sorry, new queue. So it should be this and this, right? Oh, interesting. So it's not really hitting some of these. So for DX and DY, DI, DJ, uh, print, DI, DJ, minus 1 comma 0, 1 comma 0, 0 comma 1 equals to 1. So maybe is my valid check like maybe I'm checking this wrong or something. So if 0 is less di is greater than or equals to 0, less than len grid, and 0 is less than or equal to dj less than.
Okay. We're pretty much at time. They're 45 minutes.
Okay, okay.
Okay. So how's that for you? How do you think you did?
Uh, so since like I don't know, I feel like I got I think I got the first question right, and I think this is close to the solution. Probably like, is this close to the solution by the way? Like, is this how you do it?
Yeah, you're getting really close. You're getting
Okay, yeah.
close,
So
but
conceptually, it's sort of like the same, right? Like similar.
yeah, you're close. Yeah. You just need to play around with it a little, and it's gonna work. But
Yeah. Okay.
it's not
Yeah. So
working
I'm
yet.
like, like when I started, like I like completely blanked out because like I was so nervous. So like I couldn't think for a while, but like I feel like after like maybe like 5, 10 minutes, I was like, okay, you know, I was like more back to normal. But like this was like very good for me because like it was sort of like, like you're streaming this, so there's it's sort of high stakes in a way.
Yeah.
So it kind of stimulates that sort of like interview feeling because I was like kind of nervous waiting for this as well. So yeah, so it's probably going to be similar for the interview as well.
Yeah.
So in that way, it was pretty helpful. So it's because I've been doing mocks from like this website, but it's not the same because it's more chill in that mock.
Yeah.
This is like I feel like this is more realistic.
Nice.
So yeah, it was very helpful. And I think I did okay. I don't know. What do you think?
Yeah, I would say the first part of my notes, like you misread the question at first, and I think
Yeah.
you're
For the
having, yeah, you misread the question, so you were doing like validate the apprentices with
yeah,
the stack, but
yeah, you're right.
like, yeah, you would have solved that if I gave that to you for sure, because you pumped out that algo. But after you realized that you need to switch, so yeah, same thing that happened with the last candidate. He kind of thought
Yeah,
it was something else, and he decided to go with it right away. He misread it, so
yeah,
always
exactly.
think twice.
Yeah, you're right. Yeah, I feel like I need to like like when people say like there's like a template like you need to ask like clarifying questions and
Yeah,
then so on and
exactly.
so forth. Yeah, I feel like that's I need to follow that more. Like I have to like be like strict, especially for this and as well system design as well because I find myself like falling into these traps. So like there's the problem solving side of it and there's also like like time management and like like following the patterns whatever so on and so forth like learning how to like interview as well.
Yeah, exactly.
Yeah,
So yeah, follow. Yeah, that's good advice to yourself. Like just literally follow. Always clarify. Always come up with at least one clarifying question, even if it's dumb.
yeah,
Like, oh, do we have
yeah,
no or something like. Even if
yeah,
even
you're
if
right.
it's simple, it's you need to at least clarify a little bit. Um,
Hmm.
yeah, I think you need to work on your backtracking algorithm. Have you have you practiced a lot of backtracking algorithms?
Oh yeah, I've done like I feel like I've done a lot of those, but I probably need to go back in, like
Yeah.
especially in these like time pressure, like as I said, like I was so nervous, like I couldn't think properly. Yeah,
Yeah.
I literally couldn't think at all. Like also, what the
Alright. Yeah, cause okay, you clutched that one eventually, but just required the hints. So
yeah, yeah,
for the rotten oranges, yeah, I think conceptually you're there as well. Same with the first
Mhm.
question, but getting it to actually be working code, you just didn't get to
Yeah,
for both of the questions. So
you're
this
right.
one,
Yeah.
I don't know what's happening here. I think.
I think it's somewhere. It's kind of this part maybe or
Yeah, I
something.
think the code's even getting a little bit more overcomplicated. So, I mean, you should try to work this solution out on your own and just
Yeah,
memorize this
yeah,
how it's gonna look, because this is
yeah.
boilerplate BFS. So I think
You're right.
so. Basically, the last question was boilerplate backtracking. This one is boilerplate BFS. So I think
Mhm.
just you should be able to master both of these so that if they ask you a small variation, you already have the
Yeah,
boilerplate.
you're right.
But other than that, like yeah, I think definitely kick out the interview for at least a few weeks because
Yeah,
you want to get it down, and you could like just try. I would try to push it out as far as you can, like even a month,
you're right.
as long because you only get one shot, and if you miss the shot, they're gonna make you
Yeah,
interview 6 months from now or
you're
a
right.
year from now. So usually, if I have the chance and I'm not prepared, I would always just push it out
Yeah. Yeah,
unless
What
they're
What do you think?
saying or go ahead.
Yeah, what do you think is the best strategy to kind of like because like do I like go by like patterns? Like do I practice patterns or like
Yeah, I would go pattern by pattern. So for
Yeah,
example, you should solve this rotting oranges. You should spend a day
yeah.
solving this rotting oranges, then solve like 5 or 6 more BFS questions like walls and gates and
Mm-hmm. Mm-hmm.
um, do number of
Mm-hmm.
islands using BFS. Just do a
Mm-hmm.
bunch. So just do pattern by pattern until you get it
Yeah.
down. So like spend a day doing backtracking. So do like this parentheses one, then combination sum, and there's so many different ones. Just so you
Yeah,
could
you're right.
see, go pattern by pattern, and then just start doing Amazon tagged.
Mm-hmm. Mm-hmm.
Yeah, you
Yeah.
need to like spend a day ironing out one pattern. But like yo,
Yeah,
you're
by the way,
almost there. You just need to do like 5 or 6 more BFS ones, and
yeah, yeah.
by like the fourth, fifth, and sixth, you should be typing it out so fast.
Yeah,
That'd
exactly.
be the goal.
Yeah, I mean, like the fact is, like I've seen this problem. Like, I've worked on this problem before,
Yeah,
right? And the fact that like given like the environment, like like the time pressure and all of that, I still couldn't properly complete this means that like I need to work on it a lot more. Like even the generate parentheses, I probably worked on it
yeah. No, they're
because it
classic
seemed
questions. Yeah.
yes, yeah, yeah.
But yeah, I only asked you these because they asked me these questions. Like it's too
Oh
specific.
really? Yeah.
I went through their process before, but this was like 4 years ago. I asked this.
Okay.
So,
Yeah.
but what I'll tell you from my interviews with them is they ask classic code questions and they like to prioritize graphs.
Hmm.
Make sure in the behavioral that you're mentioning leadership principles, so have different stories for each of the
Yeah, you're right.
leadership principles, and you should
Yeah.
prepare that. And yeah, they won't make you run the code, but they're gonna ask you classic questions like this.
Yeah.
All right, man. Good luck. Let
All
me
right.
know if
Thank
you
you
need
so
to do
much.
another one. Yo, yeah, practice for like 2 weeks. Go pattern by
Yeah.
pattern, and book another
Yeah.
one with me, and let's see
Yeah.
how you perform.
Okay. Yeah. Yeah. I probably want to do this like more often because I'm like that's what I do. Like I'm like practicing sort of like every day.
Yeah.
So I'll probably book it more frequently if that's okay.
Okay. Yeah. Sounds good. I'll
All right.
send you.
Thank
Yeah.
you.
Email me. Okay. Peace.
All right.
All
Thank
right.
you. Thank you.
Have a good night, man. See ya.
Thank you. You too.
Yeah. We'll get him prepped for Amazon.